So now on this screen, what we're going to be doing is simple. I'm going to just tell you what we're going to do in steps. The first thing we're going to do is that actually in programming, or when you're writing programming code, you need to first of all have a clear understanding of what you want to do. Because for me, I feel programming is 90%, if not even 95% reasoning and 5% code. Even given with the rise of AI tools of that, at the click of a button, pam pam pam, you have written the code you want to write. So programming for me is just basically you reasoning, you prompting the AI, you telling it what you want to do, you thinking of what you want to write, rather than you start writing code haphazardly. So the first thing we're going to do here is that we are going to import all the necessary things we want to import. After we import it, we will define our enable, create our function to sell token to people. So the first thing we are doing is that we are going to import our license. After we import our license, we put our pragma solidity and import our enable from OpenZappling. This enable is going to give us access to the only owner modifier that we're going to be using in our function. Especially if we want to use any function that is supposed to be called exclusively by the owner of that contract alone, that is why we are importing this enable here. So now the next one we are importing is our interface. This interface is the one we created in the previous what am I saying previous? In the previous slide, right? Now you import your contract, you write your contract. Now when you write this contract, you are saying vendor token is ownable. This ownable is supposed to have your, now then I put it, I see no argument pass. Remember the first screen where we were, it means that I need to have a constructor here that we initialize this ownable. Here is that I need to have a constructor that will initialize this ownable constructor as, or let me say, I need to have a constructor inside my constructor. Shit, okay, that's a little bit confusing. Let me show you what I'm talking about. So now in this my constructor now, this ownable, this one you are seeing here, it means that the message.sender or me, I have to initialize it as the owner of this contract. You know, I said that we're going to be accessing the only owner modifier. It needs to know who is the only owner, and that is me, which is the message.sender. This is a constructor, and the constructor is being called once in a lifetime, like once in a lifetime of this project. So the next thing I need to do is to initialize the token interface. I remember when I was telling you in the previous slide that the token interface is going to be initialized with the token address. Like this token address you are seeing now is the token address of this mint token. Let me open it so that people will be seeing what I'm talking about. This mint token, once I initialize this mint token, the contact address that you are going to see here is what I'm going to pass in this constructor here. So the next thing we're going to be doing is going to be writing our function to sell our token to the user. Let me explain all this line for you one by one. So we're going to start by selling this token. So this token is going to be payable. The reason why the word payable is here is that immediately user calls this sell token, this payable will collect the message.value. When I mean message.value, I mean the money that the user sends immediately this token happens. Wait, I think I should. Let me just scroll down a little bit. Let me just show you what I'm talking about so that you just okay. Now here, if you go here, this is my remix, right? I'm using remix to test this. Now this value here, this value is the amount of ether you are sending, or way, or whatever you are sending. If I put, let us say 111 here, this is my message dot value. Whatever is coming in there is what is going to enter. That's what makes this contract carry or receive money, or it, or way, or gwe, as the case may be. Now when the user sends money in here, the money is going to be stored in what we call address.this. It's going to be stored here. Address.this is the contract address of this whole contract you're looking at, which is this vendor token. This vendor token, the address.this you are seeing here is the contract address of it. So when the user pays in, let us say to it, it's going to be storing in here this address.this, this one here. You get. So we're going to do the first require. We're going to say that let's be sure that the user is sending money. So if the message of values, okay, we are requiring that the message of value must be greater than 0, or else if it's not greater than 0, give the user an error saying you need it to do this, right? Or earth, anyone you want to call it. So now the next thing we're going to do is to get the amount of token we need. Now you see what I did here. I'm using this precision here in case the user wants to get his amount per, the tokens per amount to be. Now for instance, now currently what I'm doing here is the tokens per ETH. I'm setting it to be 0.5. Why you are not seeing 0.5 here is just basically, this is just it basically. I'm doing 500 divided by 1000, which is equal to 0.5. So it means that I'm setting per 1 ETH. If a user send me 1 ETH, I'm giving them 0.5 token. That's very poor actually, but it's what I want to do. Now let us not say that I want to not do this. I want to set my tokens per ETH to be 500. What I mean is that every user that sends me 1 ETH, I'm going to give them 500 token. Are you getting it? But every user that sends me 1 ETH, I'm going to give them what? 500 token. So okay, there are some errors here. So yeah, because I deleted the precision. Let me remove the precision so that you're going to understand it very well. Now, the math that I'm doing here is amount of token. That means the amount of token that the user wants is going to be gotten from this. That's what I said. The user send this. And by the way, this message of value, whatever I'm sending here, Ethereum has a way of converting it to 1E18. So that's why I'm dividing it by 1E18. For instance, if I send 1 here, if I send 1 here, even if I even put ether here or whatever, or put way or fini, if I send 1 here, what Ethereum is sending to this message of value is 1 times 10 raised to the power 18. So to curb that, or to make that not to be, because if I not put this 1E18 here, if I just times whatever I have here, which is 1 times 18, if I times it with the tokens per ETH, I will be having 500 quintillion. You don't want to give a user 500 quintillion, do you? So that's why I'm dividing it by 1E18. So this 1E18 will cancel out whatever is even coming here as the 1E18 there. So I'll now have like the Odindi value. In Yoruba we say Odindi. So if you know, I'm not a Yoruba boy actually. So we say 1 times tokens per ETH, which can be 500 in this case. So I'll just give the user 500 tokens, right? So the next thing we're going to be doing is we're going to be getting the available balance. The available balance is going to be, now this token that you are seeing here is the token of the interface that we initialize up here. You can see it. This is the token of the interface that we initialize up here. So and remember, our interface has a Let me open it for you. Has one of the parameters of our interface here is balance off. This balance off means that I'm going to be sending an address, and this address is going to return a uint 256, and this uint 256 is the balance of this address. The balance of this address. You get the idea now, right? So that is what I am doing here. I am doing the token dot balance off. And when I say token dot balance off, and I send this address dot this address dot this is getting the address, the available balance of this contract that we are sending. Now let us now say that I've gotten the available balance, and the user is trying to buy too much. Let us say he's buying a billion. If he's buying a billion of our token, remember when we minted our token here, we just have only 1,000. Oh, it's just 1,000 we have, right? But the user wants to buy. It's just not 1,000 per se. It's 1,000. Okay, it's 1,000 times 118, so it is more, like it's 1,000 quintillion. But then I say the user want to buy 1 million quintillion, it will just tell him, Oga, you are buying too much. That's what I'm saying here. The next one is success. This success now is saying this token, remember it also has a transfer child there. Look at it here. We did balance off and we did transfer. So this transfer on also returns a boolean. That is why I'm having a boolean here. So it's going to be required to be successful, or else to just tell it, or it will just say failure. So let me continue. No, don't worry. Let me now write the code. Let me not use the. So the next one now that we want to do after we've transferred, let's say for instance we want to check the balance. Let us say we want to check balance of user. Let me type now. So I need to first of all get the address of the user, right? Address of user. But just that this thing will make the video longer. So address of the user, and make it public, and it's going to return. It's going to return a uint 256, right? So how do I get the address of the user? I need to first of all access whatever balance the user have. So I will just first of all start with the token. I will first of all create the uint 256 balance equal to. Now I can access the token dot balance. Remember we have balance off. Remember, so this balance off now is going to tell us. So I can now say return balance. You get the idea. So this function is going to just basically return the balance of the user. What next do we do? Let us now say we want to get a quotation. When I mean get quotation, that means we want to know. We don't want to buy you. We just want to know how much. We want to know how much. Like for instance, I want to check if I put into Ethereum how much they are going to give me. So let me check. So let us say get quotation. Let's say we're going to accept a value now, which is the amount. This is going to be the amount that I want. Amount is going to be public, and is going to be. Is it going to be view? Is it going to be view? Or is it going to be pure? View or pure? Well, let me think. It's going to be view. The reason why it's going to be view, we'll find out soon. But what I'm thinking is that it's going to be view because I am just viewing am just viewing the. I just want to just view whatever is going to happen. I'm not modifying it. I'm not modifying anything that is happening here. So what I mean by I just want to just view only the returning statement. I'm not modifying anything in the code. So let them say uint results. The result is going to be the tokens per earth multiplied by the amount divided by. I need to put this in brackets, mathematics now before this thing fucks you up. Divided by 1e18. Now this one will just tell us return. This one will just tell us what we are going to get if we put in so and so amount. So what other function again? Let us now get the function to which other function again which other function do you, I would have said do you suggest we do? Let me do a function to get the balance. Get balance of the contract. Get balance of contract. That means I want to know how much the contract now has. How much? This one is going to be a view. This one is going to be a view as well. So I can just say return straight up. Return token dot balance of address dot this. Remember, address dot this is telling us that this is the contract that we are interested in. So which other function again do we have here? So have I gotten the balance? Okay, have I gotten my balance? Okay, check balance of user. Let me call this buy token, not sell token. Buy token. Which other function do you think we're going to need? I think this is basically it. So the user can buy, the user can let us do the one for withdraw, so that we're going to access that only owner. So let's say function withdraw. Let us say I want to withdraw everything. Yeah, withdraw all it. Yeah, withdraw all it. So this one is just going to return. It's going to just return no, it's not going to return anything. It's going to, and that's going to be a payable. The reason why it's going to be a payable because I'm going to be interacting with money here, so and it's going to be public. I want it to be public, but it's still going, even as much as it's public, it's still going to have the only owner modifier. Where will I put it now? Only owner. This only owner is going to, means that it's only the owner that can call this function. So let's first of all we need to get the balance. Let's get the balance of that the contract has so that we can transfer it. U into 56 balance. Okay, that's it already. Thank you. Autocomplete. Now the next thing we're going to do is to transfer the money. Now to transfer this money away from here into my own account, which is the user. I can't say token dot transfer here. Excuse me. I can't say token dot transfer here. If I say token dot transfer here, what that token dot transfer means is that I am transferring the token to somebody. I get what I'm saying. I'm transferring the token to somebody, right? I don't want to do token dot transfer. I want to transfer the money to me. And Ethereum does that simple. I will just have to wrap my address, because I can just say address. First of all, you need to, what it's just basically saying is that I need to take my address and send money into my address, right? So I will just say payable, then wrap my address around it. Now this owner, I'm going to be using this owner. This owner is from ownable. This owner is going to be returning this owner is going to return my address. Remember that address that I set at the top, that message was sender is going to return it there for me. So I can say owner transfer, put in the amount I want, which is just basically the balance, and that's it. Let me put does this one return success? This is supposed to wait, I'm coming. Okay, yeah. Does this one return success? I don't know the return type, but let me check. I don't know actually, but let me check. Bool success. Let me see if it returns success. Did it? Okay, it doesn't. So let me see the error. Okay, yeah, it doesn't return success. So. Because I wanted to like use a what do you call it? Use a so, but let me add the require here, because remember the checks, effects, and interaction. Let me add the require, saying which require now. Or let me say require. There is no money. Oh God, there is no money here. Remember, you have to. So I'm going to require that the balance must be above 0, or I'll say Oga, no money for here. So that's just it basically. So let's test the contract and let's so the first thing I'm going to be opening is the mint token. I'm going to come here. Yeah, mint token. I'm going to mint it. So once I mint it, it's going to not enough gas. Okay. Let me use this one. Mint it again. Okay, successful. So this is it being minted. So I can see the owner here. This owner now is me. You will see it now. This is me. I'm the one who just did this. Let me check name. This is the name. Should be the name of the contract. Joseph token. Right. My symbol should be JPT. Total supply should be. You see, is 1,000 quintillion. If you count the zeros here, it's going to be 1,000 quintillion. So yeah. Now let us. So I have to copy this address. Copy it now. Because of my interface. Because of the interface. Now I'll come here to this vendor token. Now, when I want to deploy this vendor token, it will ask me for. It's going to ask me for the contract address, because on the constructor, I'm telling the constructor that I'm going to pass in a contract address. So it's going to ask me, oh yeah, where is my contract address? I'll pass it in. And once I pass it in, it's going to see it has deployed. So now that it has deployed, I need to send money into this vendor token, and I will go in here. I will go into this mint token, because there is a function there called transfer. So I'm going to transfer to this address. I just copied it. Let's say, how much will I transfer now? Let's transfer 5,000. So 5,000 of my tokens. I've transferred it into the contract. So I'm sending it into the inventory of the contracts, so that I can sell to other users. So now if I come here, let's get the balance of contracts. If I click on get balance of contract, you see the 5,000 showing there. Let us say the quotation. Let us say I want to get 1 Ethereum. 1 Ethereum should be 18 zeros. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. What I should see here should be 100. I mean, sorry, 500. Look at it. 500. So my 1 Ethereum per 1 my tokens per Ethereum is 500. So that is why I'm saying 500. So let's now say now that let me use another contract. So I'll come here, select another contract. Let us say I want to use this contract. Let us say I want this contract now and withdraw all my funds. never even put to, but anyone withdraw. We'll see what they go tell am. So this one failed, obviously, right? It should fail. So you see, the onable has already even cancelled the guy already. Like that's why we use that onable modifier there. So let us now let the guy now buy, since the guy can't no say no fit thief. So me come buy. Let us say he wants to buy 6 Ethereum. So I should give him 6 times 5. That should be 30,000 tokens. So let's say he clicks on buy token. So it's going to go successful. That is successful already. So let us copy the guy address now and check the guy's balance. Check balance. So let's check the guy balance. You see, 3,000, which is 6 times 5, which is 3,000. So the guy has 3,000 worth of my token. The other guy has 3,000 of my token in his possession. I get what I'm saying. Now, let us not say now that which other thing again can we do here? Which other thing we can do? So I think that's basically it. So yeah, thank you for watching. Thank you for staying tuned. Have an excellent day. I keep coding. Yeah, thank you.